Okay, here's my second video, or depending on the order you're seeing me do these in, whatever. I know, because this is geometric series, so I have to upload this one second, because this is the easiest series test. And so this geometric series is probably the easiest type of series you'll come across, and once you kind of do a lot of practice problems, it should kind of pop up in your head automatically. Now, geometric series, by this point you should be familiar, well, if you're watching series videos, you should be familiar with sequences and how sequences work and everything. Yeah, at least have some basic understanding of sequences. You've already looked at geometric sequences by this point, at least I would hope. If not, then you should fight your calculus teacher or hire me, pay me $10. That's besides the point. So, say we have this summation right here, or this series, from n equals 1 as it approaches infinity. Not as it approaches infinity, but from 1 to infinity. And we have this constant a times r to the power of n minus 1. Alternatively, you might see it n equals 0, a times r to the power of n. It's the same thing. And what we get from that is a plus, and then we get a because if we have n equals 1 and then we plug that up into the exponent, then we get r to the power of 0, which is just 1, which explains why we get this a constant right here. And then we go to 2, and then we have r to the first power, and that explains ar. And then you keep doing that over and over again, and then that'll be your sequence. Now, to find out whether this is convergent, the only condition we really need is that this r value right here is less than 1, is absolutely less than 1. So you take the absolute value, it's less than 1. It doesn't matter if it's negative 0.5, it'll still be convergent. Now, if it is convergent, then to find the sum, you just do this constant a over 1 minus r. And again, if it has to be the absolute value of r is less than 1, and if your absolute value of r is greater than or equal to r, or 1, sorry, then you're automatically divergent, and you should just call that problem quits. Now, kind of understanding the notation alone is going to be confusing, so we'll go through. Okay, for sake of clarity, the first example I'm going to give doesn't involve any summation notation. And that's just because it gets annoying. So we have 1 over 8 minus 1 over 4 plus 1 over 2 minus 1 plus 2 minus 4. And you can kind of see a pattern automatically, but we have our a, right? A is our initial value, which is 1 over 8, right? What we want to find is our r. So we know that the first term is equal to a, right? And then our next term is equal to a times r. So what happened from this to go to this? So we know we went negative, so that's an obvious answer. And then from 1/8 to 1/4, we know you'd have to double, right? So our r right now is -2. We can check this by multiplying -1/4 by -2, and then we get 1/2, which is what we get. Do that again, you get -1. Do that again, you get +2, and again -4, and you get that for as long as you go. So now we have our a and our r. What we need to find is our sum, right? So our sum is, am I recording in 4K? Okay, our sum is a over 1 minus r, our absolute value of r. Now, if you noticed something, which I should have noticed automatically, you'll see that our r, the absolute value of our r, is greater than or equal to 1, which means automatically we don't even have to look at the sum because we know this series is divergent. And that kind of makes sense if you look at the sequence. If you keep doing this and doing this forever and ever and ever, you're going to get infinitely large numbers adding and subtracting each other. And so that's not really going to converge to a single value, or intuitively it doesn't, at least. So this is what we have for our first example. I'll go over some harder examples, maybe 3, maybe 4, depends on how I feel. Okay, we're back in slightly worse video quality, hopefully the same audio quality, and just as easy problem. So we have here 1 plus 0.4 plus 0.16 plus 0.064. Now, automatically, our A should be obvious. That's always the first term, right? Now, our R value. This For this one, it should be pretty obvious because what do you multiply 1 by to get to 0.4? That should be pretty obvious that our R is going to be 0.4, right? And it's positive all throughout, so it's, I mean, it's just going to be positive. And then we can verify this by 0.4 times 0.4, that's going to give 0.16, and then bam, bam, bam. So once you do it more and more and more, you get kind of that intuition, and geometric is by far the easiest, so get ready. And since the absolute value of our R, or the absolute value of 0.4, is less than 1, we know we're convergent. Okay, now what do we want for the sum? So the sum we know is A over 1 minus R. And now, since we are convergent this time, we know that we can actually do this math instead of start it like an idiot and it's divergent. Okay, anyways, we know our A is 1, and then 1 minus 0.4, we get 1 over 0.6, right? And then that would just be what? 10 over 6, since it would be 1 over 6 over 10, and then you keep change flip, blah, blah, blah. 10 over 6, which I'm not going to try to approximate that in my head. I suck at math. But that's your answer. That's what it converges to. That's what all of the sums converge to. And that makes intuitive sense this time because you're adding smaller and smaller and smaller and smaller numbers. So it's kind of, if you imagined it as a slope, as an x and y curve of all of the numbers that we're adding up, you'd have this 1, and then you'd have this 0.4, and then this 0.6, and then it would kind of look like this line that gets closer and closer to some value, and that value being 10 over 6. So this is another problem. I'd say probably easier. It's just that sum part that we had to do. And next problem, which will involve summation notation. Okay, here's the first one that kind of makes you want to die, right? Um, so we have this summation right here, this series, sorry, and our starting term is n equals 4, and we're going to infinity. In our actual body, I guess a sub n is what it's formally called sometimes, and you'll see the notation either almost always in n or k. I just like n better because duh. So we have 1 over 5 to the power of n, right? Now, our first term, our a, we could just do that by plugging in the first term. So we put 4 for n. So we have 1 over 5 to the fourth. 1 over 5 to the fourth. And you should know 5 to the fourth. That's just 1 over 625. And so that's your a. So remember that. Now, what we want to do to find r, it gets kind of complicated. Now, there's two ways you can logically approach it. You can just, one, consider, okay, so we start with, say, 1 over 5 to the 4, and then we go to 1 over 5 to the 5th. And then, imagine that's a 5. I cannot draw. Why can't I? I'm sorry. Wait, no. Okay. Okay, and I still did it bad. 1 over 5 to the 6th. And then we keep going, going, going. Now, what do we notice we're doing each time? Each time we're multiplying by 1 over 5 times 1 over 5. And so you kind of notice that pattern, and it becomes evident that your r is 1 over 5. R equals 1 over 5. Now, Okay, and we can see that the absolute value of our r, or 1 over 5, is less than 1. So that means we know we converge. So that's kind of the first given. And now what we can do, since we know it converges, is that we can find the sum, which is just equal to a over 1 minus r, right? Oh, okay. Now our a, we know, is 1 over 625. And then all of that is over 1 minus our r value, which is 1 over 5. And now what we can do from there is 1 over 625 over 4 over 5. And then we do a keep change flip. So that gives us what? 5 over 4 times 625, which I can't do the math in my head, but that should be what? 0, 0, 2600. I might be totally wrong, but something like that. And then you can simplify that because 5, so you would get 1 over, I don't know, I can't do that math. Actually, no, I'm determined. Of course I don't have my calculator. You know what? No, it's a good idea. I'm keeping 15% because, okay, so we have 5 over 2600, which simplifies to 1 over 520. And that's the sum of this series. Quick edit, because I realized I'm an idiot. So 4 times 625 is actually not 2600. I did the math completely wrong. I was completely wrong. It's 2500. So then it becomes easier to simplify, and you just get 1 over 500 for the sum. And then that's your answer, and ignore the last clip. Okay, since I couldn't really find a harder problem, because geometric series are typically that easy, the hardest thing about geometric series is sometimes the manipulation. Instead, I'll show you a really quick, important limit that you do sometimes have to remember for um, just general series, because sometimes you'll see this value. So we have the limit as n approaches infinity of 1 plus a over n to the n, right? And so this, you kind of can't draw this out of your own head unless you're some freak. That gives you e to the a. So it has to be in this form, though. Well, not exactly. Okay, I'll explain it better in a second. But we have this a right here. So whatever is in this a spot right here is e to the blank power. So it could be 1 plus 2 over n to the nth power, and we get e to the 2 as our number. Now, an important note about this is that this can be written in different forms but still be equivalent. So we have the limit as n approaches infinity of n plus a over n. Now, this is the same thing, of course, to the power of n. That's the same thing because, I mean, what you're doing is just finding a common denominator. So you multiply this by n over n, which still equals 1, and then you add it to that a, and you get the same thing. And of course, it's still equal to that e to the a power. And now the last case we have is the limit as n approaches infinity of, um, yeah, okay, n over n plus a to the n. Now, this one, it messes with you because it's just the reciprocal of that, but you still get the same outcome nonetheless. And yeah, it's really, really want to look for is to this nth power. And if you see that to the nth power following some easy limit inside, then it's probably going to be e to the a something. And sometimes you'll have to do a lot of tricky manipulation for these. And that's why it's kind of an important limit to memorize if you haven't memorized it already. Um, Although I don't know why you would. So, yeah, that's it for this area. I was going to cover telescopic series, which is kind of similar. They're not bad, but I figured that should have its own video, or I should at least prepare for that better before I approach that. So